Audio level okay? Awesome. So I'm going to talk about the construction piece and the monitoring piece from the stance of it kept my vegetables in good shape. I didn't do much more monitoring than that. So that's me. I don't know. Whenever anybody gets up here, they always talk about the background of the farm and that kind of thing. And I guess what I can say, family farm on Elkhart, near Elkhart. We've got 350 acres that's been in the family for a century. My story is that I lived in Sweden for 7 of the last 9 years and was trying to figure out a way to come back and earn a living off of the farm. And so getting into vegetables seemed, at the time, like a good way to do that. Give me another year or two before I confer whether or not that was indeed a good idea. So one of the things I think helped me to be somewhat successful in my first year was adding a walk-in in order to be able to store produce. And of course, whenever you talk about building your own thing that's often done commercially, there's a high level of optimism involved. So we can start from that optimistic the plan. What I did was to build this thing last year, so I was preparing to do a 25 or 30 member CSA, and I wanted a place to store produce. So basically what I've got now is an 8 by 16 structure, 8 feet tall. I'm guessing it cost about $1 a day last summer to run. I don't have, because it was tied into power for the rest of the farm, I don't have that broken out. There are budgets. Nick, do you want to help me with those? So if you want to see some of the numbers in the construction, like the supply list, you got that. Cost me about $2,700 out of pocket. I use a lot of existing supplies when I can. And I'm guessing it took me about 60 hours of my own time and 10 hours of some assistance time to get the thing built. So the facility, the structure that I'm putting it into, this is an old granary that my grandfather had built in the 50s, and it's quite unique in that it's entirely wood construction and it's rectangular for grain storage. So you don't see that a lot ever or anymore. But basically there's 5 bays in here, and each of the bays had a vent system. So that is where my air conditioner sat as part of the CoolBot unit. It's also, Rich loves this. He came out and saw it. Like, northeast corner of the building is perfect. It's the least amount of direct sun, so we're already being smart in terms of thinking about location and that kind of thing. And then just to show you the front of the building is about 40 feet deep. I have an 8-foot cooler, so there's 30 feet of usable space still in front of it. So again, it's quite well protected from direct sun. Being an engineer by training or education, I had the perfect plan going in terms of how things would look. This is a top view. These are joists that would go across the ceiling so that I could set full pallets of produce on top and store them. The pink is my 4 inches of rigid foam. The dark green then is the shelf, the outer wall, the support walls. Just to say again, from an optimistic standpoint, I went in with a pretty good plan, and of course as you start doing things, they get adjusted a bit. So again, you have a plan and you have what actually happens. Great. So I guess it's important for you to know, if you're thinking about doing this on your own, that's the kind of mentality that I come from, the approach that I have. Like, there's a plan, and then you're going to have to adapt. And it seems like I ended up going back to Menards about 62 times over the course of 10 days to get whatever I forget. So more practical pictures again. One of the things I wanted to be able to do was to put pallets of heavy things on top. And because I had salvaged 2x12s that were about 12 foot or 14 foot long, I knew I could use those as joists up on top. So I went with 2x6s for walls to enable those joists to have support. Of course, I'm on cement, so I wanted to use green treated lumber. We have had termite damage in parts of this building before. So being conscious of that, I think another good reason to use green treated lumber. From a food safety standpoint, obviously that green treated lumber is far away from my food, so that's not a concern for me in terms of contamination. I'm going to show you a few more pictures and I'll try and explain on here. So again, stud walls, I built new walls inside of my existing structure, so I'm not using any existing walls, partly for support reasons, partly for convenience reasons, partly just because. When I was putting those joists in, I was very conscientious about having a smooth surface on the inside because that's where I was going to mount the rigid foam. So a lot of times when you do construction, you're more concerned with how the outside is being square and you'll make it up on the inside. These 2x4s are just temporary supports when I was setting those joists on top. Really do ask questions. I always talk too fast and don't give people enough time to look at pictures, so feel free to interrupt. I should probably say a little bit about the insulation that I used. I knew I wanted 4-inch rigid foam on the inside, and I knew that I was going to have 2x6 walls that I wasn't going to put foam into, and so there was an opportunity to use some extra fiberglass insulation to add even higher R values. So I did that, and I also knew that fiberglass insulation, because of the temperature difference, it could have potential problems with moisture. So here we're putting Tyvek house wrap moisture barrier up around the outside of the cooler. Sorry, I don't remember what I've got coming for slides. There's insulation. So this is the ceiling. The camera's kind of pointed up at the corner. These are the walls. So the Tyvek is around the outside, and I'm starting then to put out rolled insulation. There again, corner shot. So now here are the walls. Again, they've got, I think it's R13 or R11 insulation there. Some spray foam in the gaps in that corner, and then again the 4-inch rigid foam is going over the inside of this. So I ended up, the 4-inch rigid foam is R20, so I ended up being about 33 for an R value, which is high. I think it's pretty good. I don't know what commercial coolers even are. Any idea what a commercial?
It can be up to 6 inches of foam, I know of.
Well, that's about what I'm competing with then. Some of the practical things. This is the doorway, so you're inside the cooler looking out now. You just see some of the Tyvek. It's not a very good picture, actually. This 4-inch rigid foam. So again, 4 inches is pretty thick. It comes in 4x8 sheets, and it's not very cheap. It's one of the higher. I mean, that was half of the budget that I spent. So as I'm realizing this, and again, being the kind of guy that tries things out, and if I don't like it, I'll revamp it at some point. I didn't want to glue the 4-inch foam to the studs, to the joists, because I wanted to have some flexibility with it. So I ended up putting maybe 4 or 5 fender washers in a sheet, figuring that if I ever had to deconstruct, it would be relatively easy to take those off and plug the holes and reuse the foam.
Where'd you get the 4-inch foam?
Menards. It is a special order to get 4-inch foam. You have to order, I think it was 24 sheets. I needed 22, so I do have a couple extra sheets. I mean, it comes out, I think they're about $50 a sheet, so there's a couple extra sheets sitting around I'm saving for a rainy day. Thought sometime I might try building a cooler for the back of my pickup to take to the farmer's market or whatever, but I haven't gone that far yet. And just my slightly sloppy carpentry, so you start out with a perfect plan and then, oops, I didn't think about that until I started piecing things together. So I ended up having an 8-inch gap down the middle of the ceiling, so I filled that with with one of those extra pieces and some spray foam. My door solution, this is one of the things I didn't really figure out until the very end, but I'm quite happy with how it turned out. So what it is an insulated exterior door that came framed. Found that for $20 at an auction. And then I took some more of those fender washers and attached a full piece of foam to the back of it. I think I might have had to cut off 2 or 3 inches for clearance to make it work. But basically what that does, well, I'll show you the next slide in a second. But I did have to cut out a handle for the door from the inside. So that's probably the weakest or the leakiest spot in terms of the conduction of energy through the door handle. Notice there is this lip here. The next picture is going to show better, but what happens is this is the door jamb where the door is closing. I don't know how to illustrate it in a good way, but I don't know how to do it. Basically, there's a lip, and I really like that lip because it prevents any air from flowing directly out of the cooler. It's either got to go around the foam and then through the door or something. So innovative solution that I like. Doing the door that way, of course, I realized when I was trying to open the door, there would have to be a gap in the foam so that when that foam sheet opens, there's probably a better solution for this. I haven't figured out what it is. So there is that bit of a gap there. Again, there's R13 insulation behind it, so it's still fairly tight, but maybe that could be improved. I knew we were going to do this session after lunch, and I wanted to keep you awake. So just a bit of engineering humor. I don't know that I actually used any WD-40 on this. I probably used duct tape at some point. Back inside the cooler. So this is what it looks like mid-season. I've got containers and coolers, and there's some Brussels sprouts sticking out there that didn't get covered. But a lot of people ask, what do you use for light inside? So I've just got a trouble light, mechanics light, that kind of thing, with a 12-watt fluorescent light on it. Don't tell Rich, but I leave it on all the time because it's connected back behind. It's just hard to turn on and off. And that was enough light for me to work in it to get what I needed to get. Yep. Did I insulate the floor? Yes. So concrete floor, not a good thing from a cooler standpoint. So I've got 4-inch rigid foam. This is one of the discussions Rich and I did have early on when I was starting to construct this, is what is the compression of that foam? How much weight can I put on it? And I don't remember what it is. I think it's like 100 pounds a square inch. I'm like, so if my brother, who's 50 pounds heavier than me, is carrying a full cooler of stuff and walks in with 1 foot, how many square inches are in his foot? And is he going to go through my foam or not? Turned out he wouldn't, so it was okay. And I did put 3/4 inch plywood down on top of the foam, which helps distribute that weight a little bit. Very important point, Rich will emphasize that. I think having that floor insulation is critical. So good question, thank you. From an engineering standpoint, one of the other things I thought about was having weeds. So we've got weeds growing up outside of this building. And of course, the weeds are collecting that sunlight, so it's not hitting the outside of the building. Complementary piece of that is having the air conditioner stick out. So I'm using a CoolBot here with the air conditioner, making sure the air conditioner's got good flow around it. So I knock the weeds down 2 or 3 feet around that, but I let them grow up otherwise, again, to absorb that sunlight. There's just a little bit later in the year when the weeds have died off. I actually had to switch air conditioners, so the first day of my fall share delivery, which was like October 1st, my air conditioner conked out. I'm not sure if it was because it just got cooler temperatures and one brand of air conditioner didn't like functioning at cooler temperatures. I don't know what exactly happened. But that's why in an earlier picture the air conditioner stuck way out of the hole here, and this air conditioner fit in a little bit more tightly.
How many BTUs on your air conditioner?
The one that I used in the summer was 22,000, and the one that I replaced it with in the fall was 12,000. And I did that because any new air conditioner that I tried to find wouldn't fit in the hole, and I didn't have time to try to cut the hole bigger. Practically, I'm unsure of what's going to happen next summer. I think as long as I'm not trying to cool produce down too much, to remove too much of the field heat, that this 12,000 will be fine for what I'm doing. I can show you a spreadsheet to explain why I think that. But I think when we as produce growers are thinking about how we run our operation, one of the things I did last summer was, because I was small enough, I had everything out of the field between 8 and 9 o'clock in the morning, so there's never a lot of field heat building up. If you're trying to harvest broccoli at noon or later in the day when it's already hot and you need to get it cooled down quickly in order to maintain its quality, then there's different ways of cooling produce. I know several PFI farmers that have been doing this for a long time that use their walk-in to take out that field heat. And so you need higher BTUs, more cooling capacity in order to do that, to move air quickly enough.
So do you just leave the air conditioning on all the time?
So do I leave the air conditioning on all the time? Well, yes. Not that it's turned on, not that it's necessarily running all the time, but the thermostat is controlling it all the time. Yep. hey, look, air conditioner size. So again, during the summer I had that 24,000 BTU unit. In the fall I replaced it with one a bit smaller. I mean, it'd be interesting actually to see how comfortable am I with a smaller air conditioner in the summer and can relate that back to energy use. I think that's pretty much everything I just said. CoolBots, I think most people are familiar with those at this time, so that's the website address if you're not. Basically, all a CoolBot is a $300 device that allows you to overrun the air conditioner. So the lowest setting on an air conditioner is often like 55, maybe 60 degrees, because that's what normal people want there. You never want your house to be cooler than that. When we're using an air conditioner for this, obviously we want the cooler to be down in the probably upper 30s. And so that CoolBot basically just tricks your air conditioner sensor into thinking the room is 60. And then the CoolBot, when the room gets to 38 degrees, the CoolBot stops tricking the air conditioner and it shuts off just like it normally would. Yep.
When you say it shuts off, does the fan shut off?
The fan does not shut off.
Yeah, okay.
Well, you can set it actually either way, I think. I would leave the fan on to keep some circulation in there. One thing from a design standpoint, you saw that my air conditioner was on the long wall in the cooler, and commercial cooling people would not advise you that way. They would say put your cooling unit, your fans blowing from the short wall so that they're blowing out across the whole cooler so you get better circulation. My setup didn't really allow for that very well. If I ever were to replace the air conditioner with commercial cooling equipment, so an after-chill evaporator and a condenser, then I would mount that such that it was blowing across the long way. So I was trying to think, if we're talking to an audience that's thinking about doing this, what things did I do that I would say you should do or I should do again? I do the location in terms of being inside a building, existing structure, especially northeast corner is a great location. It's protected and not much sunlight. Trick in terms of cutting straight in a 4-inch piece of rigid foam. I used a handsaw for that with 2x4s or 1x4s on top to be the guide. Getting those straight edges, obviously it's helpful to have those butt joints that you don't have to fill so many holes. That worked well. Things that I could do better. You saw that 8-inch gap down the center that I had to fill in. I know there's a way to take 4x8 sheets and build a box where you don't have to have gaps, or you do not have to cut any sheets and make it work. I still haven't figured out how to do it. I know there's a way. And then, yeah. So there's a puzzle for somebody. Maybe you guys in the front row would like that puzzle at some point. Yep, Paul.
Your door opens to the inside?
Yes.
How about the outside?
I think what I think my thought process was I might have big equipment out in front or packing tables. Maybe thinking about carrying containers in, I can actually push the door open with my knee now if I've got something coming in from the field, so I don't have to set it down and open the door.
I was just thinking of that gap that you have to leave for the door to be able to swing in.
Yeah.
You have it in your phone, get open to the outside.
Well, yeah, but then you couldn't do the lip on the inside. You'd have to do the lip on the outside, and then I think you'd have the same problem.
On the inside.
Yeah, you're right. Well, then you have a smaller door. Yeah. If you could do it, not have a smaller door. If you had the lip, had a 36-inch door, and then your lip was 8 inches of it, you'd lose some of that carrying. I mean, that's the thing. Maybe to do is to build a bigger door, actually. You think about carrying coolers and such into this.
Wait, so what are the dimensions of your, like
The floor, the inside of the cooler.
The inside of the shell that I built, well, I had flexibility. I think I built it right at 8x16. And so in terms of storage space, you lose 4 inches off of that for foam on either side. I've said that already a few times. Bottom point here could be relevant though, from a CSA standpoint especially, where you're handling lots of different produce, often wants different temperatures and different ideal temperature, different ideal humidity. One of the things I think I'll do in the near future is to add a second cooler so that I can keep one in the high 30s and one in the low 50s or mid 50s probably. So I can keep tomatoes and peppers and those kinds of things not at room temperature 80 or 85 degrees in my unconditioned space, but not have to cool them down to 38. So you could do that in this space, I suppose. I don't know if you could really do it and control it with a single air conditioner.